Hey, hello everyone. Good evening. Yes. So we have Yasharth Kesarwani here. Good evening. Keshvi Bagela, Papiya Das, Fenil, D. Deepak. Yes. Ram Gaikwad is here. Good evening, Anvisha. Good evening, Bhagyavardhan. Divya Palekar, Papiya Das, Aditi Datya. Hi. Hey, Aditi Mishra. Hi, it's someone. Hi, Shweta Chauhan. Good evening, fun with twinkling stars. Hi, Ashoka B. Maitri, good evening. Pavitra. Devendra Singh. Hello. Hi, Mohit Patil. Hello, Gungun Tagore. Good evening, Charvi. Sonali Singh. Joshita Sushant Sharma. Learning is fun. A very, very good evening to all of you. I'm doing good and thanks for asking. How are you all doing? Yes, good? Yes, Bhavya. Enjoy edits. Bhumika Rajawat. Yes, Agrima Singh. Anushka Sinha, class 10. Khushi. Yes. Newcomer here, but I see your recorded session. They're amazing. Thank you, Shalvin Trivedi. Thanks a lot. All is well, yes? Great, great. Super excited. Well, I am excited too. Charvi revised all the formulas. That's good. Because by this time, we all should be well versed with it, yes? So we all know what today's session is all about, right? Today, we are going to discuss all the formulas that we have in term 2. Most awaited session, right, Fenil? Yes. Good evening, Fatima Rasha. Thank you, Sonali Singh. Thank you, Mahi Arya. Gahana BG. Yes. Good evening, Nidhi Gupta, Yash Chaudhary. All right. So there is no glitch at all. So we can begin now. So let's not waste any more time here. Let's start with this session. Problem with surface areas formulas. Don't worry. Whatever doubts you have, you can ask today and you can get them cleared. I'm sure that you would love this session. All right. So let's start the session. So as I said, we are going to discuss the term 2 formulas, right? So first, let's take a look at all the chapters that we have in term 2. So first we have quadratic equations, arithmetic progression, circle, construction, some application of trigonometry, surface areas and volumes, and statistics. 7 chapters you have, right? And we have done concept capsules on each one of them, and we have done questions, critical questions as well. Yes, case studies we have also discussed. All right, so one by one, I'll be discussing formulas from each of these chapters. All right, so let's begin. Let's start off with quadratic equations first. So what all topics do we have in quadratic equations first of all? So here we have the standard form of quadratic equations, right? We have zeros, roots and solution, different methods to solve, and we have this topic nature of roots, right? So you want me to teach all the subjects? Oh my God. Thank you, Gungun Tagore. All right. So these are the topics that we have, right, in quadratic equations. So one by one, I'll be discussing this. So there are few important terms that we have. We know what a general standard form of a quadratic equation, that's ax square plus bx plus c equal to 0, that you can see right in front of the screen. All right. And here 2 is what? That's the highest power, that is representing the degree. See, we are doing a quick revision, right, of all this. All right. Yes, definitely, Keshvi. Please go ahead. Right, Mahi Arya. Circle proving is difficult. That's easy. That's not difficult. Thank you, Maitri. PDF after this session, definitely I'll provide you the PDF for this session. Don't worry. All right. So where A, B, C over here are what? They are the real numbers, but there is a restriction. A is not equal to 0. If you remember, we have discussed this earlier as well. A should not be equal to 0 because if A is equal to 0, then this equation will no more be quadratic, right? All right. So 3 important terms when it comes to a quadratic equation: zeros, roots and solutions. See, what are zeros? Zeros of a quadratic polynomial are, let's say polynomial is x minus 2, x minus 2. That's our 2 and 2. These are the zeros of the quadratic polynomial. I'm emphasizing on this. See, I'll tell you one more thing here. When we talk about roots, we say roots of quadratic equation, that's going to be again 2 and 2. So it's a misconception over here. Many times I have seen that students use zeros and roots interchangeably. They feel that it's the same thing. It is not. When we use this term zeros, it is used for quadratic polynomial. When we use this term roots, it is used for quadratic equation, right? So please note down this thing somewhere, because these are the points I don't think anybody will tell you, because these, as I told you, it's a misconception. People use them interchangeably, but there is a difference. Thank you. Fun with twinkling stars. Good evening, Srishti. All right. Chapter 5. Please name the chapter. Name that chapter. Which chapter you're talking about? I hope it went well, Mahi. Yes? Yes. When you say a quadratic equation, when we talk about an equation, it is equal to 0, right? When we are saying polynomial, it will not be equal to 0. It's just an expression over here, right? I hope your doubt is clear now. Yes. Zeros for quadratic polynomials, roots for quadratic equation. Absolutely, Charlie. Right. Arithmetic progression. I'll be discussing all of the chapters. Don't worry. Right? So I hope this difference is clear to everyone now. Now coming to the solution. What is the solution? So the values of the unknown variable, whatever variable is there, like here we have the variable x, which satisfy the equation. So that is called the solution, right? So here x equal to 2, it is satisfying this. So we call it the solution. All right. All right. Let's move ahead. So these were the important terms when it comes to quadratic equation. Now let's take a look at the different methods that we have to solve the quadratic equation. So two methods are there. We have factorization and we have quadratic formula. Yes? Right? All right. Yes, Keshwi. So let's discuss the factorization. Now factorization is one topic that you have been doing for the past 3-4 years, right? Because we start with this in grade 6 or 7th maybe. So what do? Simply we split the middle term first of all. This is the general form, ax square plus bx plus c. Split, we take the product of these two, right? A and c, right? And we split it up like this. So 9x square minus 3x minus 2 equal to 0. If you use this example, simply 9 minus 2 is going to be minus 18. You split that up, right? And we take the pairs. So we have 9x square minus 6x plus 3x minus 2 equal to 0. We factorize this equation, 3x minus 2 plus 1, 3x minus 2 equal to 0. Then what do? We simply equate each of these factors to 0 and then you get the final answer. So 2 by 3 and minus 1 by 3, right? That's how we do it. Now one thing over here, I have seen many times that this factorization, maybe you have been doing it for the past few years, but few students still find it confusing. Why confusing? Because we know that we have to take the product of the first and the last extreme terms and then we have to factorize it and then we have to pick up the factors accordingly depending on the sign and all over here, right? Kind of confusing for some of them. I'm not saying for all of you. So if you don't want to get into all this and you don't want, to think about all this, the signs and all, there is one more way to solve it. So please pay attention. 9x square minus 3x minus 2 equal to 0. This is what you have. So what you will do is, simply we know that what is sum of zeros? Sum of zeros is basically minus b by a, right? So minus b by a from here is going to be 3 by 9. That's going to be 1 by 3. Then you find out product of zeros. That's c by a, right? That's going to be minus 2 by 9. This much part we all know. Srishti, please refresh the screen once. Yes? Right. Absolutely right, Keshwi. Just refresh it. Yes, it's basically a trick. If you don't want to, factor the numbers and then you have to pick the pairs accordingly, you can use this. This is a good one, I'm sure. So just do a little bit of practice of it. Once you get the heck of it, you would find it amazing, I'm sure. All right. So sum and product first you have to find out, right? Then what you have to do is, sum is 1 by 3, right? You take the half of it. Half of it would be 1 by 6, right? And in the equation, variable is x. Simply write 1 by 6 plus x and then you write 1 by 6 minus x. Every time we do this, we take half of it, we write plus x minus x like this and it should be equal to the product. What is product here? That's minus 2 by 9. Now you solve this. That's a plus b, a minus b. So a square minus b square. 1 by 36 minus x square equals to minus 2 by 9. Absolutely right. Sometimes splitting is hard. Then you can use this way, right, to solve this. It is easier. In that case, you do not have to think about splitting. You do not have to think which pair to pick so that we get this middle one, right? Middle number. Yes. So you can use this method over here. Now just simplify this. What do we get? We have x square is equals to what? That's going to be 1 by 36 plus 2 by 9. Simply x square would be equal to 36 and this is going to be 8. That's 9 by 36. So from here I'm going to get two values for x, right? That's plus minus square root of 9 by 36, which is going to be plus minus 1 by 4. But this doesn't end here. Now what you need to do? So this much part is clear to everyone. This is simple, right? Okay, this is simple. Now what we need to do is, here we had 1 by 6 plus x, 1 by 6 minus x. Simply put here, 1 by 6 plus x, just write 1 plus 1 by 4, or even if you write minus 1 by 4, that is also okay. You will get the same answer, right? And here we have 1 by 6 minus x. I'll just simplify this, right? So what do we have here? This is going to be 12, this is 2, and this is, sorry, this is going to be, this is 1 by plus minus 1 by 2, because we are taking the root of it. Sorry, I missed that thing. We are taking the root of it, so simply you will write 1 by 6 plus 1 by 2. Even if you write minus 1 by 2, you will end up getting the same answer, right? So that's 3, that's going to be 4 by 6. You get 2 by 3. See, it's matching with it. Another one, 1 by 6 minus x. I don't have ample space here, so I'm writing here. So that's, let's say, minus 1 by 2. You get 6 here. This is 1, this is 3. That's minus 2 by 6 minus 1 by 3. See, we are getting the same answers, right? See, whenever, let's suppose you have to factorize it. If you want to use a factorization method, you are comfortable with it, it's okay. It is for those students who find that confusing, right? Who find it confusing splitting the terms, then picking up the right pair. You can use this method. After the session, you can try out this method with different questions, right? So that you get better understanding of it. Yes, 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 yes. I hope it's clear to everyone. Yes? This way also you can factorize an equation. Quickly just write in the comment section so that we can move ahead. Yes? I'm waiting. It's correct. Nobody is going to cut marks for this. It is correct. Lots of thumbs up and I can see. Yes? Okay, completing the square is not coming in this year's syllabus, right? So obviously in the exam they will not ask you to use that method. So prefer using factorization and quadratic formula. But let's suppose in your rough notes, if you are doing that in any rough page, you're using that method, then it's okay. But on your exam sheet, actual answer sheet, do not use completing the square method, right? Okay, we can move ahead. So this was about factorization method. Then we have the quadratic formula, right? So this is the general form. And how do we find out the roots? In this case, we have minus b plus minus square root of b square minus 4ac by 2a. And we all know what b square minus 4ac is. That's basically the discriminant, right? Instead of this, you can write d as well. Correct. So these are the two values, right, that you get, where b square minus 4ac would be greater than equals to 0. One important point I would like to add here, that quadratic formula, this method you can use where factorization method is difficult to apply. Sometimes this happens. You have such large numbers, right? Some students are okay factorizing it. Like I also prefer completing, the factorization method more. But for the ones who do not like that method, who find it difficult to split the terms, they can use this quadratic formula because this is just the direct method, right? Direct substitution is there. Completing the square method, please students, it is deleted from this year's syllabus. So don't think about it. It will not be asked in the exam. If you just want to learn that method, you can watch the recorded session. I have explained that method as well. That's okay, Saif, it's okay. Okay. All right. So this was about quadratic formula. All right. Now, as I said, we have nature of roots as well. This is the general form of the quadratic equation, and d is what? That's discriminant b square minus 4ac. It helps us to check the nature of the roots. So if b square minus 4ac, that means if d is greater than 0, we say that it will have real and distinct roots. If d is equal to 0, we say roots are going to be real and equal. If it is less than 0, we say it has no real roots. So if roots are real and distinct, it is going to be minus b plus minus root d by 2a. They are equal, so that's minus b by 2a. Both of them are going to be equal. And if there are no real roots, then it's not valid. Question ends there. You do not have to solve it further. Okay? Yes? Graph 1 in statistics, I use games. No, that is not coming. It is deleted from this year's syllabus. Yes. Yes, Diksha Sharma. When you find that factorization is complicated for a particular question, you can use quadratic formula if it is not mentioned in the question. See, if the name of, because it's a subjective paper. So if the name of the method is mentioned, then you have to use that method only in that case. Okay. All right, all right. Clear, D Deepak? Yes. Hi Barsha. Yes, Mr. Awesome Facts, graph is not coming. You're talking about the algebras. No, that is not coming. All right, all right. All right, so let's move ahead. So in quadratic equation, let's take a look at this mind map. What all we have the standard form that we discussed. We discussed about the roots, zeros and solution, the important terms, and I told you the misconception of roots and zeros as well. We talked about the different methods, factorization and quadratic formula. You can use this method when you find factorization difficult. For factorization, I've given you another way as well. Yes. And we talked about the nature of roots. Is RS Agarwal necessary to solve? See, it is not mandatory to solve a particular book. First, your first preference should be your NCERT. Then, important questions from NCERT exemplar. Once you are done with it, do these sample papers I would suggest you, right? Practice sample papers. Yes. Alright, alright. So this was about quadratic equations. Now let's move ahead. Let's take a look at the next chapter that we have. So now we'll discuss chapter 2, that's arithmetic progressions. Okay, so these are the topics that we have in arithmetic progression. So we'll be discussing about the general introduction, general form of AP, nth term of an AP, and some of first n terms of an AP. Alright, so what is an arithmetic progression actually? It's basically a sequence of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term, right? We know this. So, how is it actually represented? Let's suppose we have 1, 3, 5, 7, and 9, right? This is basically representing an arithmetic progression. That's basically a AP's, right? AP series. So here you can see that every time I add 2 to the preceding term, we get the next term, right? So here first term is represented by A, and over here plus 2 is nothing but that's the common difference. It's basically the difference between the consecutive terms in an AP. Yes, and we denote this by small t. Yes, what an amazing session. Great explanation, great technique. Thanks, Spiders, for making maths easy. Thank you, Pulkit. All right. All right. Let's move ahead. Now we will talk about the general form of an AP, right? So when we talk about the sequence of the form, it's basically A plus D, A plus 2D, A plus 3D, A plus 4D, and so on, right? That's the general form, right? Where A is the first term and D is the common difference. Okay. So when you talk about the nth term, what is the nth term? That's an is equal to a plus n minus 1d, where an is nothing, that's the nth term, a is the first term, d is the common difference, n is the number of terms in the sequence. Any doubt till here? Yes, somebody said that arithmetic progressions is a difficult one, right? The formulas for arithmetic progressions. Quickly, if you have any doubt, you can write in the comment section. Mahi Arya, no ma'am. Rishad is giving thumbs up. The legendary gamer, wow, pro teacher ho aap. Thank you. Okay. How we take number? Which number, Arvind Singh? Sorry, I could not understand what you're asking. D Deepak, no. Aditi, no. Mahi, no doubt. Yash Chaudhary, no doubt. All right. Let's move ahead. Let's take a look at the next topic now. Sum of first n terms in an AP. So, sum of first n terms, we denote this by Sn. That's equals to n by 2, 2a plus n minus 1d. First term is a and common difference is d over here. N is the number of terms, Sn is the sum of first n terms. What each variable is denoting here, you should know that, right? It becomes easier for you to solve a question. One more important thing I would like to add here. This formula is applicable for every question, like whatever question you get when you have the first term, you have common difference, you have n, you can apply this formula. And if I talk about the second formula, it is actually coming from the first one only. See, the first formula, we can split it up like this. I can write it this way. N by 2, 2a can be written as a plus a, right? Plus n minus 1d. And we know one thing, that this much part, a plus n minus 1d is nothing but that's an, right? The nth term. Nth term, or you can say the last term. So I can say it's n by 2 a plus l. So you can see from this formula only we have got the another one. And the second formula is applicable when the first term and last term is given to you. So it depends on you whether you want to use this formula or not, because the first one is applicable at all times. Let's suppose first term and last term is given. You do not have the common difference. In that case, you would require the second formula. But now I told you, so it's not that you have to cram it up, you have to mug it up. So you can see that how we are getting the second formula from the first one. Yes, Arvind Singh. Yes, that's correct. That's how we take when there are three numbers, right? Yes, this is clear to everyone. डी दीपक सेकंड फॉर्मूला यूज किया तो मार्क्स नहीं कटेंगे ना. सेकंड फॉर्मूला यूज किया नहीं, एब्सोल्युटली नॉट दीपक. It's there in the NCERT as well. I was just telling you how you can derive the second one from the first one, so that you don't have to mug it up. Also, one more thing, second formula is only applicable when you have first term, last term and the number of terms, right? Let's say you do not have the last term, so in that case you won't be able to apply this formula. And definitely, marks will not be deducted. It is there in the NCERT. SolidWorks official. Yes, definitely. Please, whatever doubt you have, please write in the comment section. All right. Ma'am, if N and L value is not given, if not given, what to do that? If N and L is not given, see, understand this thing. Let's suppose if N is not given, L is not given. Some other information would be given in the question, right? Question will not be formed just like that. Some other information would be there. Using that information, you will be finding out some value so that you can apply any of these formulas at the end. Yes? Thank you. Thank you. All right. All right. Thank you, Charvi. Yes, Seth. Please ask whatever doubt you have. Yes. All right. I think no one has a doubt till here. It's clear to everyone. So shall we move ahead? Quickly, yes. Yes, I'm waiting. Thank you, Sonali. Ma'am, first we find last term and then we use it, then it's acceptable. First we find last term from where and then we use it. Then also it is fine. Let's suppose you find out the last term first and then you use the formula. It's okay. But why do you have to go through all that hassle? You're increasing the number of steps. Straight away you apply this formula, but it's completely up to you. If you want to go that way, that is also fine. Yes? Session on case studies. We have already done it. You can watch the recorded session on YouTube. Yes, Mahendra Kumar Singh. I'm repeating it one more time for the ones who haven't understood. See, you all know this formula, right? Now I can split this 2a as a plus a. We know that a plus n minus 1d is nothing, but that's what? That's the last term, nth term. I can write nth term as L also. So from the first formula, we have derived the second one. No need to mug up, right? So you can apply this formula when you have the last term, you have the first term, you have number of terms. Otherwise, if you have common difference, first term, n, you can apply this formula. Okay, I tell you one thing. Whatever information is given to you, first you jot down all that information. And then you see out of which formula for the maximum things are given. Accordingly, you apply the formula. Okay? Right? All lessons. All right. So I think it's clear to everyone now. Yes? Let's move ahead. Now let's take a quick look at what all we have in arithmetic progressions. So we discussed about the general formula of AP. We discussed about nth term in an AP and some of first terms in an AP. Right? Derivations will not be asked in the exam. Don't worry. Thank you, Arvind Singh. It's going to be subjective. Derivation will not be asked. Ma'am, the formula to find the first sum of first n terms of positive odd numbers, in which formula we use. So first n terms of the positive, right? So here when you are talking about n, any formula you can use. Both are okay in that case. Yes. All right. Let's move ahead. Let's take a look at the next chapter that we have. Now we'll be discussing circles, which is chapter 3 here. So let's first take a look what all we have here. I'll be discussing the basic terminologies first. Then we have 2 theorems in this chapter, right? So we'll be discussing each one of them one by one. Let's first take a look at the basic terminology. So when you talk about a circle, so the region between an arc, right? This is the arc. These are the endpoints of the arc, right? And the 2 radii, that's called the sector. So here you can see this is the minor sector, and this part over here, that's representing the major sector, right? All right. Now similarly, what is a segment? It's region between a chord and the arc. So this is the arc and that's the chord. This is the minor segment. And this region over here between this arc and this chord, that's called the major segment, right? Yes. So this is clear. What is sector? What is segment? Right. All right. And then what is a tangent? It's basically a line which touches the circle at exactly one point. So this is a tangent to the circle, right? At one point, there can be only one tangent to the circle, right? Yes. Dhyaneshwar Flare. Yes. So what is a sector? When we talk about a sector, it's basically region between arc and the two radii. This is an arc over here, minor arc. These are the two radii. So this region over here, that's minor sector. Now this is a major arc and these are the two radii. So this region over here, that's the major sector. Yes. Similarly, when we talk about segment, that is the region between chord and arc. This is the region between arc and two radii. Remember these keywords over here, right? That's okay, Papiya. And tangent is basically at exactly one point. There can be only one line touching the circle. That's the tangent. Yes. All right. So let's take a look at the first theorem that we have in circle. So tangent at any point of a circle is perpendicular to the radius at the point of contact. This is a circle over here. This is the center. This is the tangent. You can see radius and tangent are 90 degree. So they will always be 90 degree at the point of contact. Yes. Right, Mahiyarya. That's what theorem 1 is. Yes, proofs of the theorems are coming for both the theorems. That you need to prepare. All right. Yes, solid work official. See, sometimes, you know, the chat flow is so fast. Sometimes I might miss out a few questions, few of your doubts. Yes. All right. Let's move ahead. Let's take a look at the next theorem now. So next is basically the length of tangents drawn from an external point to a circle are equal. This is a circle with center O, right? This is an external point. From here, two tangents are drawn. We know that radius and tangent are always 90 degree. So we prove these two triangles congruent. Using that, we can say that this PQ and PR are going to be equal. They will always be equal, right? So this is what this theorem is saying, that the length of tangents which are drawn from an external point, they will always equal in length, right? Thank you, Aditi Datta. All right, let's move ahead. Let's take a quick look at what all we have covered in circles. So we talked about the basic terminologies. We talked about the two theorems that we have. Both the theorems proofs you need to prepare. Yes. Okay. Let's move ahead. Let's take a look at the next chapter that we have. So now we'll be discussing questions from constructions. An easy chapter, right? So what all topics we have here? So we'll be talking about division of a line segment in a given ratio and construction of a pair of tangents. Yes. Thank you, Bhagyavardhan. In construction will come or not? Construction, definitely it is coming. Yes. All the chapters are important. Yes. See, each and every chapter is carrying some weightage. So I would say, if you have that thing that you want to score 100% or 90%, whatever, right, it is, whatever your goal is, then in that case I would say each and every chapter is important. Do not leave any chapter. And it's easy also, it's not difficult. All right, let's move ahead. So first we'll be discussing division of a line segment in the given ratio. So let's say we divide a line segment of length 16 centimeter in the ratio 5:3. So first of all, we draw AB, which is of 16 centimeter. Then what do? We draw a ray AX, making an acute angle with AB. Yes. So after that, since this is 5:3, total is 8. You have to do what? You have to basically make 8 arcs on this ray AX, right? Such that this A1, A2, A2, A3, A4, they all should be equal, right? All of this, they all should be of equal length, right? Now what we need to do is we join BA8 and we draw a line parallel to BA8 from point A5 by making an acute angle. Making an angle equals to angle AA8B intersecting the AB at C. Like this, you can see these two arcs over here. These lines should be parallel. Yes. Theorem 2 in circles. Yes, that's very simple. All you need to do is just prove those two triangles congruent, right? Two triangles congruent, and that's simple because we have a common because this is what we have in circles, right? This is an external point. That's the center. We know radius and tangent are 90 degree. Let's join this line. So what we have here, let's say this is A, O, B, and this is P. So we know that this is 90 degree. These two angles are equal. These two are the radii. This is equal and this is common. We can prove them congruent, and then you can say that AP and PB are going to be equal. That's it. This is what this theorem is saying. Term 2 only circles is difficult. Circles is an easy chapter. See, if you have any confusion, any doubts you have in this chapter, we have done a one-shot session on circles. We have discussed very good challenging questions on circles as well. You can watch the recorded session on YouTube. Sonali, one more. This theorem or the construction one? This lesson only. Yes, absolutely final. These are so easy. No, Diksha. This is 5:3, right? Yeah. Acute angle. Yes, it can be of any degree. That's okay. Yes, yeah, Arvind Singh. Manisha Chaudhary. Okay. You're talking about this circle theorem or the construction one? Because both these things I have explained on the same slide. Legendary gamer, ये chapter क्यों नहीं हो पाएगा? बहुत simple है ये. Just you have ample time, right? So boards are going to start from 26th of April. So just practice it. Don't give up. Yes. I will be covering that, Ananya. I will be covering this as well. So here in construction, what we are doing is we have drawn a line segment AB of 16 centimeter first of all, right? We have to divide this in the ratio 5:3. We draw a ray AX such that it's making an acute angle, any acute angle, right? Then 5:3. Total is 8. We have to make 8. We have to divide it in 8 parts. All of them should be equal, right? Open compass and using that same radius, just put the arcs. Thank you, D. Deepak. Right? When they all are equal, all you need to do is join B8, the last one with this last point, B. Okay? Then what you do is, then we have this A5 because we have to divide in 5:3, right? The first number is 5 here. From here, this 5, you have to draw a parallel line over here such that it is intersecting this AB at C. These lines should be parallel. Okay, these two lines have to be parallel, make sure. Then after that, it will be divided in the ratio 5:3. Yes. I have repeated it one more time. I hope that it's clear to everyone now. See, when it comes to constructions, I would suggest you after the session, try out a few questions, but don't just draw rough sketches. Use proper your geometrical tools and then draw it. Ruchi Vadvani, I hope it's clear now. SolidWorks official, it's clear, yes? Ajit Kumar, for this one, yes, there is one more alternate method which is given in the NCERT. You can use that as well. Yes. In that case, we draw acute angles like this. This is here. Like this, we draw the acute angles and then we join like this. This is one way of dividing it in the ratio 5:3. Clear? Great. Let's move ahead. Next type we have is basically about construction of pair of tangents. So let's say we have to construct tangents to a circle from a point P outside it. So we have a circle over here, right? This is the circle. I'm highlighting with red with center O. Okay, so first of all, let's say this is the external point. I'm just drawing it for you, right? Let's say this is the external point, that's the center. Let's join it first of all. Okay, once you join it, what do? We always draw the perpendicular bisector of this joined line. When you draw the perpendicular bisector, take a compass, put the compass needle over here, right? And the radius should be equal to this, let's say PM or MO, right? Open it till that length. Then you draw a circle. It will intersect the actual circle at 2 points. Then you can draw tangents from there. That's how you can construct tangents from an external point to a circle. Yes? Okay, I'll go a little slower now. Is this clear to everyone how to construct tangents to a circle from an external point? I can do chapter circles in the whole syllabus. For me, circles is difficult. Keshvi, just practice questions. It's not difficult at all. Yes, solid work official. Is this clear now? Aditi Mishra, yes, clear. Sonali, clear. Keshvi, okay. Nireksha Bhatt, yes. 11.2, question number 4. What's that? How would I remember? What's question number 4 on 11.2? Yes. All right, it's clear to everyone. Okay, let's move ahead. So in constructions, what all we have, we discussed about division of line segment in a given ratio and construction of pair of tangents to a circles. All right, let's move ahead. Let's take a look at which chapter do we have next. Now I'll be discussing some applications of trigonometry. So first of all, we'll be discussing a few basic terminologies that you come across in the questions. Then we'll talk about the assumptions made while solving, and then trigonometric ratios of some common angles. All right. Yes. SolidWorks official. Any doubt in the construction? Yes. Once again. All right. Let me just go back. Students, let me just explain them what we did in the construction, the last one. Then we can start with this applications of trigonometry again. See, whenever you have to draw tangents from an external point to a circle, make one point clear, right? You have an actual circle with center O. Now this is my external point. I have to draw tangents from this point P to the circle. Always, your first step should be join this external point with the center of the circle. Yes. Now I'm explaining very slowly. This should be your first step. Then second step should be you take the perpendicular bisector, right? We all know what perpendicular bisector is. Okay. When you draw the perpendicular bisector, you get the midpoint. Let's say I mark this as M. Is this much part clear to everyone? Then I'll move ahead. Quickly just write in the comment section. Give me thumbs up or smileys. Yes. Yes. Thank you, Sonali Singh. Hi, Mohammad Arshad. Bhagyavardan is giving smileys. Pavitra, Ananya Pandey, Nireksha Bhatt, Yasharth, Nidhi Gupta. SolidWorks official. I explained this for you. Yes, Amit. Quickly. Okay. Then what do? We have point M here. Keep the compass needle over here. Open it. The radius should be equal to PM or MO. Then draw a circle. Right? Once you do it, what you need to do, you just have to draw tangents. All right. Let's move ahead. Let's take a look at the next chapter, that is applications of trigonometry. So these are the three topics. These are three things that we'll be discussing. Let's first start with the basic terminologies. Okay. So if the object to be viewed is straight ahead, right? Then in that case, like here, this is the observer, this is the object. In that case, the line of sight is same as the horizontal level. So line of sight or horizontal is same over here, right? So what is line of sight? It's basically a line drawn from the eyes of an observer to a point or the object viewed. Yes, this is what line of sight is, or you can say the horizontal level when they both are straight ahead. Justification, no, justification is not coming, but yes, steps of construction you will have to write. Yes. Ruchi, refresh the screen. Alright, let's move ahead. So next we have is angle of elevation. So these are the basic terminologies that you would come across when you solve questions related to applications of trigonometry. So here the angle which is formed between the line of sight, here observer is here and this is the object. Now observer is looking up, right? It is viewing an object which is above the horizontal level. This is the horizontal level and this is the line of sight. So in that case you can see the angle of elevation is formed. So whenever the observer is looking above the horizontal level, in that case angle of elevation is formed. Yes. Alright. Coming to angle of depression. So observer is here. Now observer is looking below. Yes. Observer is looking down to view an object. So it is below the horizontal. In that case, this angle over here is called the angle of depression. Alright, angle found by the line of sight with the horizontal when the point being viewed is below the horizontal level. That's the angle of depression. Alright. Okay. Let's move ahead. Let's take a look at the few of the assumptions that we make while solving these questions. So the angle of elevation of the top of the Qutub Minar. This is the Qutub Minar. It's a 3D object. Observer is here, right? In reality, what happens is, so we are not considering the height of the observer, right? make this point. We do not consider until unless it is mentioned in the question to consider it. Now we are looking at the top of the Qutub Minar. So the distance between the observer and the Qutub Minar over here is 73 meters. It is looking up, it is making an angle of 45 degrees. And over here, when we draw the figures, what we do is we consider this 3D object as a straight line and this eye of the observer over here at a point object, right? That's how we have to draw the figure. Yes. Reading, practicing NCERT book is enough for basic mathematics. Yes, that's fine. Absolutely. Line segment 10 centimeters, circle 5 and 4 on both ends. And a circle of 5 and 4 on both end of line segment, draw tangents from opposite. Same thing. Let's say this is a line segment of 10 centimeter, right? You have a circle here, another one here. From, I think, because entire question is not visible here, dot, 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 it's showing. So I think you're asking from this point, we have to draw tangents to the other one and from this point also. So same thing, take the perpendicular bisector, we have joined it already. Perpendicular bisector, it will make a circle over here. Right? Once you make a circle, it will intersect them at some points. Then you can draw tangents like this. Alright? From here till here like this. I'm sorry, it got so messed up. Right? I hope it's clear now. Yes. Alright, alright. So, the few steps that we need to follow to draw the figure. First, we represent the 3D by a vertical line like we did here. We represent the observer as a point object and we label the angle, height and distance like this. Then you proceed with solving the question. Yes. Right? Together with is good. It's good. You can practice with that book also. Oh, hi Papiya. Yes. Yes, वो बाहर चले गए हैं, right? वो tangent से ज़्यादा secant लग रहे हैं अब. But you can, you know, use the geometrical tools and properly draw it. I just gave you a rough idea how to do it. Yes. All right. Let's move ahead. So now I'll be discussing how to find the trigonometric ratios. Basically, there is a table in your NCERT, trigonometric ratios for some common angles, right? So how to find these values? Because I've seen students try mugging up this, right? See, you don't need to mug it up. I tell you a very simple trick. First, we find out the value of sine theta. Using that, we can find the value of any other trigonometric ratio for a specific angle. First, write them in this order, 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. In this order only. Okay. Then I'll simply write this as 0, 1, 2, 3, 4. Write them in this order. Right. Divide each one of them by 4. Each one of them by 4. This is the trick. Then you take the square root of it. Okay, so once you take the square root, you get 0 here. And this is going to be what? 1 by 2. This is 1 by root 2. This is root 3 by 2. And that's going to be 1. So like this, you can find out the value for sine theta for any specific angle. Yes. For surface areas and volumes. Okay, don't worry. Yes, I hope this is clear to everyone. Like how to find out the values. So you don't need to mug up this. No cramming is needed. 0 degree or 90 degrees deleted, doesn't matter, it's just a value, right? It's not a very big topic or something that you would think, okay, it's time consuming, let's not do it. It's just a value. Yes. Sine 45, that's 1 by root 2. Alright. Okay, now can you tell me how to find out the values for cos theta for specific angles? All we need to do is, we just reverse this order. Reversing this order means sine 90 degrees is 1, so cos 0 degrees is 1. Sine 60 degrees root 3 by 2, cos 30 degrees. I'm just reversing the order. Correct. Right, Mr. Awesome Facts, yes. And simply, this is 1 by root 2, this is 1 by 2, this is 0. Yes, okay. Okay, now finding out the value of tan theta. We all know that tan theta is basically sine theta by cos theta, right? So what is tan 0? What is 0 by 1? Tan 0 is what? Quickly. Yes. Generally, yes, Nikesh Mati, generally, but not always. You should know the values for others as well. Yes. So that's going to be 0 by 1 is what? That's going to be 0 only, right? Correct. Yes. And this is what? Tan 30 degree is going to be 1 by root 3. Tan 45 would be 1. Tan 60 degree would be root 3. And tan 90 degree would be not defined. Because 1 by 0 would be not defined. Yes. Yes, Solid Official, SolidWorks Official 3D. Don't worry. I'm not ignoring you. Yes, Sveta. 1 plus tan 0. See, tan 0 is what? That's basically 0. 1 plus tan 0 would be 1 only. Yes. I've answered to your question. It moves so fast. Sometimes we miss the questions. It's not possible to read the comments of each one of you. Alright, cosec theta. It's basically the reverse, the reciprocal of sine theta. It's going to be what? Reciprocal of 0 is going to be what? 1 by 0. That's going to be not defined here. Yes. Similarly, cosec 30 would be 2. This would be root 2. Cosec 60 would be 2 by root 3. And that's going to be 1. Right? Alright, yes. Sec theta. Reciprocal of cosec value, or cos values, right? So, cos 0 is 1. Sec 0 would be 1 only. Cos 30 is root 3 by 2. This is going to be what? 2 by root 3. Yes. Cos 45 is 1 by root 2. That's going to be root 2. Cos 60 is 1 by 2. So this is going to be 2. Cos 90 over here is 0. So the reciprocal of this is basically not defined. Yes. No need to mug up all this. That's what I'm trying to explain you here. Okay, coming to cot theta, it's basically reciprocal of tan, right? So tan 0 is 0. So reciprocal of this is going to be not defined, right? Tan 30 is 1 by root 3. It's going to be root 3. Tan 45 is 1. This will be 1. What is tan 60? Tan 60 degree. Tan 60 degree is root 3. So cot 60 degree would be what? That's going to be 1 by root 3. And cot 90 degree, what is the value of cot 90 degree? Quickly write in the comment section. Yes. Why, Mohit? What happened? Yes. Cot 60 degrees, Sveta says not defined for cot 60 degree. Is it so? Tan is already not defined. Not defined, root 3, 1, 1, 1. Keshwi is saying it's 1. How come it's 1? It's going to be 0. Yes. Because tan is not defined, right? That's going to be 0 over here. 1 plus, sorry, SolidWorks Official. I could not read the entire comment. Alright, so this is how you can find out the trigonometric ratios for specific angles. 1 plus tan theta says square theta will come. Theta equals to sec square theta will come. The identities are you talking about? Yes, identities would come in the exam, right? Alright, let's move ahead. So now what all we have in some applications of trigonometry, we discussed about the basic terminologies, that is line of sight, angle of elevation, angle of depression. Just basic terminologies are there. Using that, we basically make a few assumptions while solving questions, and then we talked about the trigonometric ratios of some common angles. Now let's move ahead. Let's take a look at the next chapter that we have. Now we'll be discussing surface areas and volumes. So what all we have here? We have formulas of solids, combination of solids, surface area of combined solids, volume of combined solids, and conversion of solids. Yes, mind maps make it easy to learn, right? That's why we have provided it. Alright, let's take a quick look at the formulas. Yes, Vaishnavi. So whatever question you have, you can write in the comment section. Alright, so first of all, we talk about cubes. We know that it's a 3D figure which comes from a 2D square, right? When we keep piling up squares on top of each other of the same dimension, we get a cube, right? So its lateral surface area is basically, we do not consider the top and the bottom face. Only 4 surfaces we are considering. That's 4a square. Total surface area, we are considering all the 6 surfaces. That's 6a square, and volume is nothing. That's a cube. Yes. Right. Alright, and then we talk about the cuboid, which has length, breadth, and height. So its lateral surface area is 2HL plus B. Total surface area is 2 times LB plus BHS plus HL, and volume is LB and H. Right? Difference in lateral and curved surface area. See, these are areas, right? It is not volume. If in case the question asks, in case it is something like this is asked, then you will have to find it out. Yes? There is no such formula for this, that you subtract lateral. Okay, I thought lateral and total, you're talking about lateral and curved surface area. See, lateral surface area basically, sorry, I misunderstood the question. Lateral surface area basically we use for flat surfaces, this is the term. But for the curved surface, like cylinder, sphere, for cone, they have a curved surface, so we use the term curved surface area. But if you see, the basic meaning is same. We are not considering the top and bottom in any case. I hope that your doubt is clear now, yes? Okay. Now coming to cylinder, yes? So how do we get a cylinder? Basically, if you keep piling up circles of the same dimension on top of each other, keep piling up circle, 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 such that they reach a certain height edge, you get a cylinder. Like curved surface area is 2 pi RH, right? Total surface area is, we consider the top as well as the bottom surface, they are circles. Their area would be what? Pi r square, pi r square. So in total it's 2 pi r square. So 2 pi RH plus 2 pi r square. Yes. Diagonal for 3D object. Let's say you are talking about a cuboid. That's going to be square root of L square plus B square plus H square. This is the shortcut formula that you can use. Yes, Sahul. Sure. We will come up with that as well. Yes, Trishna Mandal. All right, all right. And volume of a cylinder is nothing but that's pi r square h, because volume is nothing but that's area multiplied by height. So area of a circle is what? That's basically pi r square and height is h, so that's pi r square h. These are simple ways, tips to remember these formulas, right? All right, then let's talk about a sphere with radius r, right? Sphere has a curved surface area of 4 pi r square, right? Why 4 pi r square? See, let's suppose you have 4 circles, right? And 4 circles such that they have a radius equal to this bigger sphere r. So all of these circles, small circles, have the same radius. So we use a thread to cover this bigger sphere. And the same thread we use to cover all these circles. So the length of the thread is same. That's why we can say that the curved surface area of a sphere is equal to 4 pi r square. We add the surface areas, the areas for all of them. That's how we get it. Then we talk about the volume of a sphere. That's going to be 4 by 3 pi r cube. Sorry, Vaishnavi, I again missed your question. Please, can you just write the question one more time? Ma'am, we check what we have put, TSA or CSA? Kavya, I'm not able to understand the question. How we check what we have to, okay. How we check whether question is asking for TSA or CSA? See, it depends on the, what information is given in the question. Let's suppose I'm talking about a cuboid, right? Nothing is mentioned. We say that it's a solid cuboid, so definitely find the surface area. We will find out the TSA. Let's suppose it says that we have a room which is cuboidal in shape. Let's say it says that, and we have to paint the 4 walls of the room. We have to paint the walls of the room. It is mentioned. Now we know that we do not paint the ceiling and the floor, obviously, right? The 4 walls of the room we are talking about. In that case, we'll use the lateral surface area. That's how we can figure out, right? Depending on the information in the question. Yes. Embankment. Embankment is like, see, it's like, let's suppose if you have seen the, let's suppose I talk about a banyan tree or a peepal tree, if you see. So around it, there is basically a high mount is created of cement, right? Around the tree. That is called embankment. Even around the wells also, it is created. Yes, Royal Shitty. Dance with Aarti Saxena. Thank you. Definitely samajh aa jayega, Sahul. Please watch it. Yes, Sonali. Ceiling will also be painted if question specifies. If question is talking about walls. Yes. So walls will be considered the 4 walls, not the ceiling in that case. So that's how you need to understand the question. TSA or CSA in cylinder. Yes. Let's suppose it says that it's a solid cylinder. In that case, definitely the top and bottom is covered. Right? It says find out the surface area. So obviously we're finding out total surface area in that case. But if question specifies something like this, that it says bottom has not to be considered. We have questions like this in the NCERT also. So from the question also you get to know this, right? Whether bottom needs to be considered or not, top needs to be considered or not. Yes. Oh, yes. All right, all right. All right, let's move ahead. Let's take a look at the formula for the solids, right? Now the solids, like we have hemisphere. So we know what the curved surface area for a sphere, right? It's 4 pi r square. So since it's hemisphere, as the name suggests, hemi means half, it's going to be 2 pi r square. Similarly, when we talk about total surface area, see, it is a solid hemisphere. So it has see, like somebody just asked me how to figure out CSA or TSA. Now if the question says it's a solid hemisphere, right? And top is also, there is a lid or something. So definitely it is covered. And when we say that find out the surface area, we'll be finding out the total surface area in that case, right? So 2 pi r square is the curved surface area. And for the top, it's pi r square. So 2 pi r square plus pi r square is going to be 3 pi r square. Thank you, SolidWorks Official 3D. Thank you, Sahul. All right. Yes. Yes, Ananta Kumar, Samantare, yes. Derivation will not be asked, don't worry. Find out the number of cones. Number of cones by melting cylinder, good question. I will just explain you this thing. So, volume of a hemisphere, exactly half of sphere. So 4 upon 3 pi r cube is for sphere, take half of it, 2 by 3 pi r cube. Coming to the cone. Again, when we talk about curved surface area, we are not considering the bottom. See, we will not use the term lateral surface area. Though, if you see, the basic meaning is same. We are not considering the bottom. We are only considering the curved surface. That's pi rl. We know how to find out L. That's square root of r square plus h square. Okay. For total surface area, I'll consider the base as well, pi rl plus pi r square. Like, let's suppose, in the question it says we have a conical tent, right? And a cloth has been used to make it. So definitely, if you see in a tent, the cloth is never used on the bottom. So in that case, we'll find out only the curved surface area. Question will not specify this, but you should have that common sense that obviously we do not use the cloth at the bottom. So that's how you have to figure out. Yes, I hope I've answered to your question. Sorry, I don't remember the name who asked this thing. Yes. L is the slant height, right, Sonali Singh? Yes, Harjinder Singh, definitely, because these are the same topics. Most of these are same in grade 9th also. For surface areas and volume specifically. Hi, Lipika. Yes. Absolutely. Right. Keshwi has answered to Diksha's question. That's right. Thank you, Royal Chitti. Formula of solid shapes. So we are discussing solid shapes over here only, Vaishnavi. Like we discussed about the 3D shape, cube, cuboid, sphere, cylinder and all. Yes. I hope that you scored good, Lady Maker. Yes. All right. So, and volume of a cone is 1 upon 3 pi r square h. It's exactly 1/3 of the volume of a cylinder. Cylinder is pi r square h, right? All right, let's move ahead. Now we'll talk about combination of solids. Somebody just asked me, like, what if we melt a cylinder? How many cones are we going to get? Depends on the volume of the cylinder, right? Whether it's a small cylinder, it's a bigger one. It all depends on that. So shapes that are formed by combining 2 or more solids. What happens is that, see, whenever you come across such things, let's say, when we talk about combination of solids, here we have this conical tent, you can see. At the bottom, we have this cylindrical thing, right? Radius is R2 and height is H2. And at the top, we have this conical thing. Radius and heights are different. So these kind of conical tents are also there. Like in circus tents and all, if you see there. Yes. So these kind of tents can also be there. So based on the question, you need to figure out. Here, if you see this picture, you can see this tank over here. So here it is comprised of different solids. Like we have 2 hemispheres, right? And this cylinder over here, right? So it's basically a combination of solids. Yes? Number of cone is equal to CSA of cone by CSA of cylinder. No, Kavya Pratap. No, that's not, this is not the way to find it out. By cylinder, right? It's not necessary that we'll use the CSA only. Wait a second, I'll answer to your question. All right, let's move ahead. Now, when we talk about conversion of solids, somebody just asked me what will happen if we melt it. Yes, Kavya, I'm answering to your question only. Let's suppose we have a solid, right? That solid is reshaped. Then the volume remains the same. See, if you come across such words in the question, I'm giving you hints so that you can figure out easily. If you come across words like reshaped, or you see that molded into, or broken into, or it says melted, converted, such words when you come across in the question, that means the volume will remain the same. Like here we have got these 3 spheres, their radius are r. When it is melted, a bigger sphere is formed. So volume is same. Because when you're melting them, the material that you have, you're using the same material to form it. Again, it is melted. We formed a cube with side A. It is melted again to form the, so the material is same. What we are trying to say here is that the volume of smaller sphere, volume of larger sphere, volume of cube is going to be same. Absolutely, recast it. That's one more word that you can see in the questions. Yes. Yes, Vaishnavi, clear? Kavya, I hope that I have answered to your question. Yes? Fennel, clear? All right, all right. Cool, let's move ahead. So this was about surface areas and volumes. Now I'm sure that all of you know how to, memorize these formulas. So no need to mug up, right? All right, let's move ahead. Let's take a look at this chapter. Next we have statistics. So 3 topics that we have to discuss: mean of group data, median of group data, and mode of group data. Right? When we talk about mean is basically a measure of central tendency, which gives the average of the data. That's what mean is, right? And we have got 2 methods. One is the direct method. So mean is denoted by x bar, that's just summation fi xi upon summation fi. If xi is not there, we find out the class mark, that is xi. Upper class limit plus lower class limit by 2. That's how we find it out. Alright, another method is the assumed mean method. So where we use an arbitrary mean A, which is chosen as assumed mean somewhere in the from the middle of all the values of xi, right? So how do we find this out? Using this method, we use that x bar is equal to a plus summation fi di upon summation fi, where di is equal to xi minus a. And we have done a session on statistics also, right? I've covered all the methods that we have. Alright, and next we have median. As the name suggests, it's a middlemost number of the central value in the set, right? So median is basically L plus n by 2 minus Cf by f into h, where L is basically lower limit of median class. Yes, number of observation is n, f is frequency of median class, Cf is cumulative frequency of preceding class, and h is the class size. Absolutely, step deviation method is deleted, right? Thank you, Fennel. Derivation, no, derivation will not be asked in the exam. Please do not worry. Derivations are not coming. Just practice questions. If we use step deviation, is it wrong? Because it is, yes, do not use step deviation method, please. Use only the methods which are there in your syllabus. That's direct method and assumed mean. Please practice these methods only. Other method, if you want to know, that's good for knowledge, but do not use in the exam. Alright, next we have is the mode of group data. It's basically the value that is repeatedly occurring in a given set, right? Which has the maximum frequency, which is occurring maximum number of times. Alright, so mode is L plus f1 minus f0 upon 2f1 minus f0 minus f2 into h. What is all these denoting here? L is the lower class limit of the modal class. How do we find out the modal class? The class with the maximum frequency. H is the class size interval. F1 frequency of modal class, F0 frequency of preceding class, frequency of succeeding class is F2. This is how we denote it. That's frequent value, right, Nikesh Madri? So what all we have discussed in statistics? We discussed about mean, the 2 methods of mean, direct method, assumed mean method. We have mode and median. So there is a lot, right? Interesting chapter. And you see that statistics has made our life so easy. It really makes easy for us to analyze the data, isn't it? Yes. But we never thank to the people who have actually, who have actually discovered these things, have invented this. So, who is this? This is Kesri Sridharan Pillai. He was born on 24th February 1920 in Kerala, India. Yes, it's his birthday today. So he was a great mathematician and he made great contributions to statistics. He was an Indian statistician. And he was known for his works on multivariate analysis and probability distribution. Yes. And okay, tell me, there is one more famous personality who has his birthday today. He was born today. Who is it? Okay, let me give you a hint. He is basically the founder of a phone company which is named after a fruit. Quickly, tell me what his name is. Guess? Any guesses? Yes. He's the founder of a phone company and it's named after a fruit. Come on. Right. Nireksha Bhatt, that's apple. Aman Dubey, right. Steve Jobs, yes. Amazing. All right. Yes. So till now, you see, we have done a lot of sessions. I have done, the concept capsules I've explained in one shot for every chapter. We did critical questions as well, challenging questions I have come up with. We did case studies also, right? And today we have discussed the formula sheet as well. But still, I feel that many students have this thing that they don't really like math. You know, they have that kind of math fear, isn't it? Do you agree with this? Maths is not everyone's favorite. This is what I feel. Right, Bhagyavan? That's Steve Jobs, right? Apple. Yes. Why mango papaya? Again, papaya has come up with something, you know. Yes, Charvi, it is not coming. It will not be asked in the exam. Thank you, Atishay Jain. Yes. Vaishnavi agrees to it. Boni also agrees to it. Yes, hashtag family. Now you don't fear this because of me? Thanks a lot. Thank you. Your friends hate maths. I have also seen with so many students, right? But seriously, I feel very bad. It's a very easy subject. So, to help you overcome this fear, tomorrow I'm coming up with a session, how to overcome the fear of math. Yes. So tomorrow, which is February 25th, Friday, 7 p.m., we are going to have a session. So we'll be discussing some tips and tricks like how to overcome the fear of math. This is not a difficult subject. Nikesh Ma, we love maths. Wow. Thank you, Naman Goenka. Yes. Yes. Sure, Kavya Pratap. Yes. Thank you, Sweta. Very, very, very easy. Really? Mathematics is? Mathematics. Oh, wow. All right. So this is not the end because we have lined up many more sessions from you for every Monday to Friday to make you exam ready, and you know that we have free trial classes as well. So you can click on the link in the description below and get all your doubts clarified instantly during the class. And one more thing. One more important thing here, students were asking about the PDF for today's session. So yes, this is available in the description below. You can get the PDF for this formula sheet, whatever we have discussed today. Yes. Thank you. Amazing sisters. Yes. Fennel, not mango. Papaya will be the founder of papaya. Oh my God. You all are so funny. Yes. Thank you, Kavya Pratap. So for today's session, the PDF is available. You can check in the description below. Yes, whatever we have discussed, yes, it's there. All right. So please like, share and subscribe so that you do not miss any new updates from us. So I'll see you tomorrow at 7 p.m. All right? Okay. Thank you. Bye-bye.